Thank you, everybody, and welcome back. Thanks for joining another edition of the Extreme Performance Series video blogs. We'll have a very fun one today, very interesting one today. And joining me, we have one of the godfathers of performance. We have Reza Taheri, who has been a strong mentor of mine over many of the years here, and going to tell us about some benchmark work he's been doing recently here. So, Reza, why don't you jump in and give yourself an introduction?
Good morning. Thanks a lot for hosting me, Mark. So I'm a principal engineer at VMware. I've been here for 14 years, and I've been in the industry for 40 years, all of it doing performance work. I'm going to talk about the TPCx-HCI benchmark, and in particular, the work that we have put in vSphere 7.0 to support the performance of this benchmark and benchmarks like it. I can talk for hours about the benchmark, but I'm going to highlight one thing about it, which is it simultaneously stresses many areas of the system. And you can't hide one area of deficiency by using some other area. So for example, if your storage performance is low, you can't just throw memory at it to cache data because you get dinged in price performance. Or if your storage performance is good IOPS, good latency, but it comes at a very expensive CPU cost, then you lose performance because the benchmark tries to use all the available CPU inside the VMs in the database application. So if your storage, if your software-defined storage has high CPU cost, you get dinged.
As I understand it, this isn't like a single node benchmark either.
Yes, at least 4 nodes and at least 60 VMs, and it scales up from there. And again, because it is a cluster, the load balancing and all kinds of cluster software and management software comes into play to achieve optimal performance. First published result of this benchmark. Supermicro just published an official audited result on the TPC website. I'm gonna borrow some of the charts and pictures that they have on their full disclosure report. You can go to the TPC website and download the report, download the supporting files. This used 4 hosts, and we were pleased that they use vSphere 7.0 U2 as the software stack. They could have used a different HCI stack. They used vSphere, and performance, as I'm going to talk about, was really good, was excellent. If you're familiar with virtualization benchmarks, they always have this concept of a tile as a unit of replication. So you run 1 tile with 12 VMs or 2 tiles with 24, etc. So you increase the load and scale it up. And in this case, they had 5 tiles and 60 VMs. The benchmark kit automatically attempts to maintain a uniform overall load, but change how much of this load goes to one group of VMs versus another. This is to emulate what you find in the cloud, where you have multiple tenants. And one tenant might be selling ski equipment in the winter, and its load peaks. In the summer, its load drops, but the vendor that sells pool equipment, their workload goes up. So these up and downs force the hypervisor scheduler to figure out how to allocate resources to all these VMs so that the one that's peaking is happy, so your overall performance stays high, even though underneath everything is changing.
It's not just a benchmark testing one thing. And like you said, with those tiles and with those VMs to distribute that workload, I mean, it would look like it would uncover all kinds of interesting challenges in a virtual stack by distributing that load like that.
It has, and we have been working on this for years. And when we first started, performance wasn't great, but we have managed to bring it to the point that here, if you look at a throughput curve, so y-axis is throughput, x-axis is time. So throughput versus time, it looks pretty uniform, no problem. But that's overall for when you sum up the load, the throughput of all these VMs. If we look at the different groups here, you can see that the purple group here at one point was taking about 80% of the overall load. And then here it's down to 5%. And the scheduler has to figure out, this guy is demanding a lot more resources. Let me give it to it. And it has to maintain the right allocation of resources to all these VMs. And this is for one system. Now, if you have one node, if you have multiple nodes, 4 nodes, then you have to also migrate the VMs between the nodes so the load is balanced. And that was even more challenging when we first started working on TPCx-HCI. Here is, again, something we borrowed from the Supermicro disclosure. This is the throughput, the reported throughput for the audited result. And you can see that the throughput is relatively uniform, plus or minus 5%. But underneath, the load of the 60 VMs is going through all kinds of gyrations. And in fact, on different systems, so as the load changes, our DRS, distributed resource scheduler, has to step in and migrate VMs between the nodes to balance the load on different nodes.
When you think about that, and that's what you want from a platform of infrastructure too, right? We want to put the workloads on there. We want to know that the platform is going to maintain that. It's going to migrate for us. It's going to get data from where it needs to get data. Right. And so that we just worry about those app KPIs, right? That everything stays consistent despite everything going on underneath.
So as you know, vMotion has been one of the main attributes of virtualization for 20 years. For this particular benchmark, a benchmark is really sensitive to long tail response times. We have single-digit millisecond response times normally. So if, as a result of vMotion, that is a little longer, response times are a little longer, and even if there is a few of them, small number of it, the benchmark is very sensitive and it fails the run. You have a bad run, and you cannot use that run. A single of such violation sinks the whole run. And when we started out, even though we had very rare cases of it, it was still enough on a per run basis that most of our runs were invalid. And you had to keep running it until you get a run that was totally clear of any such violation. To show this qualitatively, I'm going to put this graph up. I have intentionally removed the x-axis and y-axis labels just because I'm going to just show you in general how much vSphere 7.0 has improved this. The leftmost column is release 6.7, update 3. So that's our baseline. And over time in 7.0, we have dropped by well over a magnitude the frequency of these invalidations. So now we get mostly valid runs.
Those kind of improvements are significant, A, for the benchmark, but two, that's going to apply to everybody in the real world, right? Anybody who has a latency type sensitive workload is going to benefit from these works as well.
Yeah, that's one of the properties of TPC benchmarks where once in a while you get into a situation where you can see that, the benchmark has a property that is difficult for systems to handle, and you can say, let's remove it. But no, TPC keeps those properties in to force the advancement of technology to deal with even corner cases, because you get rid of corner cases, as you said, then everybody benefits.
I understand this workload even has kind of an additional challenge it throws in at everybody here. Is that right?
Yes. So this is an interesting property of this benchmark. The idea of data accessibility is something that most TPC benchmarks have. And what the benchmarks typically require is that you show that the configuration can withstand the loss of a disk or the loss of an HBA, etc. Here, the data accessibility test for TPCx-HCI is the same thing, but on steroids, in that you have to show that you can withstand the failure of a whole system. So the test requires that the test sponsor ungracefully powers down a system, one of the 4 nodes, and that you show that you can continue running in the face of that. So I borrowed this graph again from the Supermicro disclosure. What I find nice about it is that the benchmark requires that you run at a high performance for 20 minutes. Then you kill the system, kill one of the 4 systems. And then you're required to turn it back on in 20 minutes and wait another 20 minutes so we observe the performance, and that's it. There is no requirement for performance after the failure, just that you continue running. And what I love about this is that it shows that here we have a little dip in performance where the system dies. Here we turn it back on, we take a little dip. Here, I think that's when the recovery starts in earnest, there is a dip. But otherwise, overall, performance doesn't take a huge hit, even though one of the 4 systems is killed.
Well, it's super neat to see, obviously, these benchmarks advance to push this idea of our virtual platforms. Right? As we all consume cloud nowadays and we all throw everything at the cloud, we take for granted all the stuff working underneath. So it's neat to see, a tool set to evaluate that. We certainly appreciate Supermicro's efforts in doing this, and we're certainly very excited that we were the first disclosure published for this as well. Reza, thank you very much for joining us today. Thanks for sharing your expertise around this. Appreciate that. And stay tuned, everybody. Look forward to seeing you at the next edition of the Extreme Performance Series video blogs. Cheers.
Thank you, Mark.